In C++ programming language, a reference is a simple reference data type. The name C++ reference may cause confusion, as in computer science. A reference is a general concept data type with pointers, with C++ references being specific reference data type implementations. In Java, we also have reference. It can be implemented as a new name for an existing object. So think of it as an object's alias. So yes, you hear me right. A reference variable in C++ is an alias, another name for an already existing variable in memory. Let's take, for example, we have an integer k equals 5. Now, this is an allocated space of 4 bytes on the stack, with this variable k being its name with a value of 5. Let's say we create a reference variable of k and name it as j and said this is k. So the way that we do that is to create integer ampersand. And when you have ampersand at the end of a data type, it signifies a reference. So j, in this case, will be a reference of k. And j being a reference variable, it is simply an alias or another name for k. So you can think of both j and k are the same instance in memory. This means that after this, let's say we change k equals 10, and if you were to do a cout j, you're going to get 10, not 5, because j is k, because j is a reference variable of k. Take for another example, let's say we do j++. At some point after you created this j reference variable. Now, at the risk of confusing you by giving a different perspective, when we said j++, the compiler generates codes that implements k. In other words, k is incremented and not j. This is what happened beneath the hood. What is important to note is we're talking about reference, and reference is not pointer. Even though a reference is often implemented using an address in the underlying assembly language, please do not think of a reference as a funny looking pointer to an object. A reference is the object, just with another name. It is neither a pointer to the object nor a copy of the object. It is the object. Now, it begs the question, what about the size of a reference? Now, if you do size of and try to cout or print line this, what would you get? And notice that when we append ampersand at the end of the data type, we're talking about a reference variable. This is a char reference variable. This is an integer reference variable, and this is a C++ string variables. Let's go to the next slide. Let's go to the definition of the size of the reference straight from the standards, and you can find out more about the standards in the above. And of course, now we're not talking about 11 anymore. There's C++ 17 and 20, 21. In the standards, the size of a reference is defined as such. When applied to a reference or a reference type, the result is the same size of the reference type. In other words, if you have an integer reference and this reference is referencing an original variable of integer type, then the size of that reference variable will be the size of integer. And the size of char reference will be the size of char. And the size of string reference will be the size of string, so on and so forth. In other words, the size of a reference variable is the size of the variable that this reference points to. And this is a very important property of reference in C and C++. The other property of reference, since we're on the topic, is you cannot just create, for example, an integer reference j and declare it as such. This is simply not allowed. When you create a reference variable, you must assign that reference variables to an object that your reference variable references, such as integer ampersand j equals k, whereas k is declared with a value. Now, whether k has a value or not, it doesn't matter, but k has to exist prior to the creation or instantiation of your reference variable. So this is very important, otherwise you're going to get into compilation error. In this case, we're calling k a referee, right? The reference variable references k. Since j references k, you cannot later on and say j equals w, right? Assuming w exists somewhere else. It won't work. This is to say that you cannot reset or reset a reference once this is already pointing to a variable to make it refer to a different object. You cannot. The important thing to know is that once a reference is bound to an object, it cannot be unseated to another object. This is the reason why in some textbooks, they said a reference is similar to a const pointer. But I must stress, especially in the context of C and C++, please do not confuse references with pointers. They are very different from programming mechanical standpoint. We will talk about pointers in a different video. Then we will see the differences between references and pointers.